12, we'll talk about rational and radical notation. So here we have a to the exponent 1 over n. That can be rewritten in a radical form as the nth root of a. And if you have a numerator m over n as the exponent for a, the base, you can the denominator always becomes your root or your index on the radical, and then whatever the numerator is the exponent on the base on the inside of that radical. So let's look at a few problems and see how we can utilize that to help us solve that. So here we have are asked to evaluate the cubed root of 8, and the cubed root of 8. We can think about 8 in terms of things that are a power of to the power of 3. So I think about that and I think, okay, 8 is 4 times 2 and 2 and 2. So there's 3 2's. So that would be the cube root of 2 to the third power. And anytime that's going on, that'd be 2 to the 3 over 3, which is 2 to the first power. So that equals 2. You can evaluate that using the rational exponent and the radical form in conjunction with one another to evaluate that. Let's look at another example here. 32 in the fifth root. Again, 32 could be broken down into 8 and 4. 4 is 2 and 2. 8 is 2 and 4. There's another set of 2's. So that's actually 2 to the fifth power under the fifth root, which is 2 to the 5 over 5, which is 2 to the first power. So it ends up working out like that. It doesn't always work that way, and so it works out. But if it is going to simplify, that's one way to do that. Example 3, we want to write 3 to the 2/5 in radical form. So again, the denominator is going to become the index on the root. So it's a fifth root of 3 squared, and we could simplify that a little bit and do the fifth root of 9 would be the way that we want to leave that to write it in radical form. So from rational to radical form. Next example, we want to simplify the cube root of 7 times the cube root of 2. And the rules are for multiplying radicals together. If they are the same radical, you can multiply them. If they are not, then you cannot. And the rules are outside times outside, inside times inside. So these are cubed roots. So this is, we don't have any, we have a 1 outside and a 1 outside for each. So 1 times 1 is 1. And then, so the cube root of 7 times 2, which is the cube root of 14, is the simplified form of that. Okay. Example 5, simplify the square root of 9 over 25. The rule is that you can split apart a radical. Anytime it's a fraction in there, you can make that square root of 9 over the square root of 25. And then we know those are easily evaluated. The square root of 9 is 3, the square root of 25 is 5, and we've evaluated that. We can use that same rule in example 6 to simplify the square root of 16 over the square root of 8. We do know the square root of 16 is 4, but the square root of 8 is not a nice number. So we can go kind of backwards from what we did on example 5 and make this the square root of 16 over 8. And that will divide evenly to the square root. 16 divided by 8 is 2. We get the square root of 2 to simplify that. So much easier way to simplify that than rationalizing the denominator. Example 7, and ask us to evaluate this with the calculator. So I want to show you a couple of different ways to do that with the TI-84. So if we're going to evaluate that with the calculator, one of the ways would be using the cubed root in the menu of your calculator. So if you hit math and the cubed root option is option 4, and then you just type in 216 and hit enter, you get 6. Another way to do that is to think about this in terms of a rational exponent. So that's 216 to the first power and it's underneath the cubed root, so it would be to the 1/3 power. So with your calculator, you could type 216 raised to the 1 divided by 3, and there we get the same solution. It is exactly the same operation with your calculator. So 6 is that solution. So let's use that to help us approximate the 7th root of 200, with their calculator. So there's a couple of different ways that they do that in the calculator. One way is to actually use the 7th root. So with your calculator, if you hit the math menu and then select option 5, it has an X in the index, and you can put in a 7 and then type in 200. Hit enter. And we're going to approximate that. Let's go 4 decimal places, so that'd be 2.1317. 2.1317. You could also do 200 to the 1/7 power. And with the calculator, 200 raised to the 1 divided by 7 is 2.1317, just like it. Calculator, either of those ways evaluates that. Example 9, the last one, is to adding and subtracting radicals. Again, the index on the radical has to be the same. These are all square roots, so that's nice. But we do need to simplify them. In order to add and subtract terms, you have to have the same radical on those terms to add and subtract them. So let's simplify the square root of 8. 8 breaks down to 4 and 2. 2 and 2, there's a pair of 2's. So that's going to come out and multiply to the 3. 6 radical 2. 18, 9 times 2, there's a pair of 3's. That comes out and multiplies to the 4 to give you 12 radical 2. 27 does break down to 9 times 3. 3 and 3, there's a pair of 3's. That's going to be minus 15 square root of 3. Two of these things are the same. One is not like those. So there we have those two like terms. 6 plus 12 would be 18. The radical 2 stays. Minus 15 radical 3. And there is the simplified version of that. Again, you have to have the radicals the same index, and then they have to have the same number underneath the radical in order to be like terms to simplify for lab number 12, Math 110.